In this video, we'll discuss some basics of NumPy. Before getting into the topic, we'll discuss the importance of NumPy. Basically, Python was not built to carry out the complex scientific computations required in data science and many other fields. NumPy makes these scientific computations possible in Python. NumPy is very fast as it has its bindings to C libraries. Most of the scientific libraries such as pandas, scikit-learn, scipy have their building blocks in NumPy. As we have discussed, NumPy is the fundamental package for scientific computing in Python. NumPy is a Python library that provides multi-dimensional array objects and various derived objects such as masked arrays and matrices. But what exactly is an array? And how is it different from a Python list? Well, an array is a collection of similar items stored at contiguous memory locations. The idea here is to store multiple items of same type together. Whereas, a Python list is a collection of similar or different type of items stored at non-contiguous memory locations. Here, the idea is to allow storage of different type of items together. Now let's compare the mechanism of memory allocation of an array and a list. Arrays have contiguous memory allocation. That is, the address of an element of an array shares a border with the address of another element of the same array. You can see this from the diagram. Here, the memory locations are continuous, whereas in a list, these memory locations may be random. So, the operations which are performed on lists take longer time compared to an array, since it has to first interpret the addresses, get the elements, and then perform the operations on them. Whereas in an array, getting the elements is much easier compared to list. Contiguous memory allocation makes it easier to calculate the position of each element by simply adding an offset to a base value. Here the base value is 56 and the offset value is 1. It has to be noted that the memory addresses in real life are actually much more complex than the ones which I have taken in the example. The memory allocation system looks somewhat like this in real life. From here, you can clearly understand that a NumPy array has a much simpler mechanism compared to a Python list. Next, we shall discuss why NumPy is faster. NumPy arrays have a better memory allocation method in terms of computational speed. NumPy array is a collection of similar data types, whereas a Python list can have different data types. This creates lots of extra constraints while doing computations on it. NumPy functions are implemented in C, which again makes them faster compared to Python list. NumPy is able to divide a task into multiple subtasks and process them parallelly. We shall discuss about parallel computing in another video. NumPy contains an assortment of routines for fast operations on arrays, which include mathematical operations, logical operation, shape manipulations, sorting, selecting, input-output, discrete Fourier transforms, basic linear algebra, basic statistical operations, random simulation, and much more. Coming up next is the coding part of NumPy. I made this NumPy notebook which contains the basic syntax of NumPy. I have explained each and every syntax with a comment beside it so that you can just study and understand. I'll also make a video which will contain all of these codes. These contain creating NumPy arrays, shape manipulation of NumPy arrays, array attributes and methods, array indexing and slicing, broadcasting, conditional selection, and NumPy operations. I'll be sharing this notebook along with the exercises and their solutions in the next video. I'll see you there. Thank you.